All right, so this is homework assignment number 3, and our goal is to do like all of the stuff that's right here. All right, so when we look at this function, always a good idea to think about domain first. So the numerator, well, we can put all real numbers, x cubed minus 27x. That's going to be defined for all real numbers. And our denominator, e to the x, well, that's also going to be defined for all real numbers. They can never equal 0. So we have new domain restrictions, right? So we can think the domain is all real numbers. Right, so then we want to find critical values, intervals of increasing, decreasing, all that good stuff. So that means first thing we want to do is take a derivative. All right, so when we take this derivative, we're going to need to use a quotient rule. So although we can factor the top, like we pull an x out, nothing would simplify. So let's just jump right to the quotient rule. So remember, the quotient rule has 5 parts. We have some subtraction in there, and the bottom squared. We knew 3 things already. We have e to the x, e to the x, and we have the top function over here. And then it's just derivatives of the other stuff, right? So we can take the derivative of x cubed minus 27x. That's going to be a 3x squared minus 27. And we can take the derivative of e to the x right here. That's e to the x, right? So we can simplify this a bit. We can pull an e to the x out of everything. And that's going to give us 3x squared minus 27 minus x cubed minus 27x all over e to the x squared. So that would be an e to the 2x technically, but we're going to cancel one of these things out anyway. All right, so we can cancel this and one of those, and then we can clean up what's inside of these parentheses, right? I have a negative x cubed. I have a positive 27x. So I'm going to write this as negative x cubed plus 3x squared minus 27 lies plus 27x and then minus 27. All right, so one more thing, since we usually don't try to factor these things, but I'm going to pull a negative out, and that's going to give us negative x cubed minus 3x squared plus 27x minus 27, this whole thing over e to the x. All right, so here we could try to figure out where the top equals 0. Kind of looking at this, I know that it's not going to factor by grouping. So like I know that's not going to factor by grouping is because, well, if I pull an x squared, I'm going to get an x minus 3 in that left part. I can only pull a 27 out of that right part. Right, so I'm not going to waste my time trying to do anything here. I'm just going to use technology. Right, so where is x cubed going to Desmos? So where is x cubed plus 3x squared minus 27x? Nope, x cubed minus 3x squared plus 27x and then minus 27. Let's see, we have x squared minus 3x squared plus 27x minus 27. Yep. So where is this thing equal to 0? Well, we see that it has one and only one 0 at that one spot whenever x is equal to 1.083. All right, so this numerator equals 0 when x equals or is approximately 1.083. Right, so that's going to be the only critical value from the numerator. We would also look at the denominator. When is that thing equal to 0? Never. So the only critical value that exists here would be 1.083. So then next thing would be, if we took the second derivative now, I'm going to take the second derivative of this kind of like reduced one, negative this whole thing in the top, and that's in the bottom. All right, so if I take this second derivative, right, we're going to get, again, a quotient rule. We're going to get the bottom times the derivative of the top, but that's going to be, I'm going to use this one here because they're equivalent and because that's just all written out already. We have a negative 3x squared plus 6x plus 27. We're going to get minus negative x cubed plus 3x squared plus 27x minus 27 times the derivative of e to the x was just e to the x. And then we're going to divide by e to the x squared. Right, again, we see that we're going to get some cancellations with e to the x. those e to the x's are going to cancel, that'd be squared, with that e to the x. And then we can clean up this top one more time to get positive x cubed. We're going to get negative 3x squared minus another 3x squared. So it's going to be negative 6x squared. We have a minus 27 plus 6. So that's going to be minus 21x. We have a plus 27 plus 27. That's a 54. This whole thing over e to the x. So there's our second derivative, right? If I look at this thing, is this going to factor? I'm going to have x plus 6 on the left. Nope, that's not going to factor. So same thing, let's just find where the top is equal to 0, so we can potentially find our inflection points. So x cubed minus 6x squared. So 6x squared plus something, minus 21x plus 54. Right, so that's going to hit 0 a few times. Going to hit 0 at negative 3, 1.8, and 7.04. Right, so we have these three solutions. All right, so we have negative 3.683. So x equals negative 3.683. Was that it? I don't know. 683, 1.879. And finally, 7.804. Okay, so those are the places where our second derivative is negative. Now we can use the graph here. I mean, use technology, right? So if I look at the second derivative, right, so we have negative 3.683, we have 1.879, and we have 7.804. And then we're dividing this all by e to the x. But what do you know about e to the x? If we're trying to look at a table of signs, e to the x is always positive. Right, so if that's always positive, it's not going to affect anything in terms of like our signs. So whenever we're less than negative 3.6, we're negative. Whenever we're between negative 3.6 and 1.8, we're positive. Then we're negative and we're positive again. Right, so our function is, our second derivative is negative, positive, negative, positive. So we're concave down, concave up, concave down, concave up. Every time we switch concavity, we have an inflection point. So we have an inflection point when x is negative 3.683. We have an inflection point at 1.879. And we got an inflection point at 7.804. All right, and then finally with the first derivative, same idea. We only have one critical value, 1.083. When we look at our table of signs, we know, or you might remember from like the graph of this thing, that it looks like this. All right, so the purple graph looked like that, but if I use it as the pink graph, because it's negative, it's going to be backwards, right? It's going to look like that. So anywhere to the left of 1.083, we're going to be positive. Anything to the right, we're going to be negative, right? Again, this e to the x doesn't affect our signs. So this means f of x is going to be increasing and then decreasing, which means we have a max value at 1.803. All right, so in terms of intervals of increasing, we're increasing from negative infinity to 1.083. We're decreasing from 1.803 to infinity. And then intervals of concave up, same thing I wrote here, concave up between negative 3.683 and 1.879, and then from 7.804 to infinity. And from here to here, and then from here to here, we're concave down. All right, so you just write that in like interval notation or whatever makes you the happiest. Man, that's a long question.